The other thing is that we have three types of volcanoes.
Yesterday we talked about the intrusions, and a lot of times those intrusions lead into the formation of volcanoes.
Sometimes.
How are they?
And in fact, yesterday we saw the.
I do want to jump down to composite volcanoes.
We saw Devil's Tower.
Composite volcanoes are very steep and extremely explosive.
That's because they are usually made out of
what
rock
volcanoes do, how they differ from one another,
how are their eruptions different, how is their magma source.
What do you know about the type of volcanoes?
One of the things I want to point out right away is notice vent. So you know the slope of the sides is literally
up very quickly.
Take a look at the slope there.
Trying to take a straw
versus the slope here.
and trying to
Feeds in the magma, or even this.
suck up the
molasses
or very heavy syrup from a
volcano?
straw. It's just not going to work well.
And this piece right here is the vent.
Yeah, as we move from left to right, we get more steep in our sides. Okay, good. What else do you guys know? Go up into the volcano, and therefore becomes our crater. Now the crater is a what?
So
Is the little
one
divot.
thing
about this.
what
What really happens with
no, that's
these,
not the content. Yeah, that's coming as part of crater lake.
is you can see how thin this neck is, or the vent. So with that being so thick, this is, it literally starts to pool, and you actually get a little bit of a blockage in here. And then that prevents the rest of the magma from going, so you get built up of pressure, you get gases that build up, and all of a sudden you get a major eruption that releases out all of those gases, releases out all the pressure and the magma. And so this is very, very severe types of eruptions.
Okay, this is not something that you want to be standing next
No,
to.
there from this point
Here,
here.
Helms, for example, that
There.
we've had other ones in our area. You guys have heard of Montserrat? Heard that?
Is
Okay.
really
That
this
is
right
a
here.
Caribbean island.
So did you actually see the small picture? Pyroclastic flows, which extend even farther down to sea level, and then all the way down to the bottom of it, which has literally created a modern day Pompeii.
A lot of our island
What is
volcanoes
Pompeii?
that we see
Are we think, oh, that's not that
are
much.
one case so special, taller mountains, which they're actually quite flat.
Oh, this has at least another.
Nobody can tell me what mountain is the bottom of the ocean base.
Water.
Water actually,
Yeah.
flat and degrees.
So
Actually, it was
same concept with magma. It exerts a force. So it's height above sea. So elevation.
Yeah, so the pyroclastic flow comes out all the ash. We're going to do the city.
And it's not that high.
Kill all the people. In fact, this earlier today, you can see the shell, the rock shell,
has to
or
go.
the pyroclastic flow.
That people much larger, way taller than so. What happens is that
Drew really kind of fall in.
I don't hate to be them,
But this is Montserrat, is a perfect example of that. I believe they erupted it
the
in
water
water.
ever turns out.
Not lava.
Pyroclastic flows. Pyro meaning what? Pyroclastic.
That's a good point.
Same concept here.
Caldera. We said about the iceberg.
All the caldera and pyroclastic flow is literally the magma chamber. Take a look at this cloud right here. See the cloud, the ash cloud?
Each one of these has a different name. We call this a shield volcano.
That has this full magma chamber.
Stop and think about it for a minute. It
This
totally
is,
makes
we
sense.
will find and then what that magma chamber was
The
doing.
composite volcanoes
pushing
have that
up.
uniqueness. They're the ones that sort of round
on the rock.
And what it
Preventing
is,
it from
is
falling
literally,
down.
as long as stuff is coming out really large stuff upward. As long as you have
This
this
one is called a cinder
good.
cone. And the magma chamber
Eventually,
starts
you
to
lose
that explosive power, and what happens?
Guys, what are
cinders? It starts to come back down. That's
So
when
now,
because as soon as that ash cloud starts descending from the atmosphere, it's traveling over 300 miles per hour, and so it literally
over
crumbles,
1,000 degrees.
and then your
You
entire
will not outrun
volcano
this. It literally
falls down
burns you
from
from the inside out.
And now
The ash that is inside the ash cloud, as you're breathing this in, you're literally scorching your lungs you're burning your mouth.
This volcano has emptied out the magma chamber so much fire to the inside out. Yeah, small these ash. So much volcano. It's kind of the same concept here with the center body. In fact, therefore, grace is. When you look at this, nobody knows what this rock. This literally cement.
Not only are you not
Black,
burning
solid.
every breath you take with that dust,
You know, it's also
a
national park.
mud mixture, clay mixture.
What does that look like?
Theirs are actually quite large.
Yeah, it
One
nobody knows about the size.
other.
Is it solid?
It's a distance of
And
it will take several minutes.
Yeah,
to get
it's
a bunch of rubble sitting around this volcano.
Okay, so that's a.
I mean, you will be very aware of what you're doing to yourself. There's nothing you can do. No, the vent is literally next. Going up inside the volcano.
It's just not fun. It's not something to play around with. It's not something to take as a joke.
Large.
In fact, look at
this
volcanic
would be
eruptions,
very, very small, very fine grains
here.
Then the actual.
Like I said, we're going to demonstrate that here, and you guys will see a little bit more about
something
that.
to take very serious.
And then our last one out here is called the composite. I am going to go ahead and model with you guys here. Your composites are your typical volcano, the ideal volcano. Right?
Yep. Picture in your mind a volcano.
Yep.
I guarantee you, for most of you in this classroom,
A composite is
Monster Rock.
Has a volcano, the erupting shaped island. Now, one thing I do want you to know is that all three of these do have in common. Last volcano we need to talk about are the cinder cones. Guys, these are extremely small.
That's also called Darrow, which was actually at that point in below sea level. So literally
Small volcanoes.
The middle one is not active.
But the other two
How many of you guys have ever seen Sunset Crater?
Middle one is actually called Sunset Crater.
That's
And
probably
that is
about
northeast Arizona.
maybe 1,000 feet tall. Series, not very large.
So again, it's all relative terms.
And
Basically what it is, we do have steep sides, but we had very, very minute eruptions.
Yes.
How many guys there at 4th of July had those?
That's really kind of cool.
These three types of volcanoes come from three different types of
erupting.
and therefore
Three different types of eruptions.
wonderful shows to watch. First one I want to talk about is the Shield volcano. Now, you guys did mention that you saw that we had a lot of shield volcanoes, sediments.
So really, when we see that surround all of
Are broad, gentle, sloping
and that's
sides.
because when this erupts, it doesn't erupt in large blocks of rock. It doesn't erupt as smooth
This
rock.
Hawaii.
It literally is blowing out dust. One thing about
So it literally just kind of spews its insides and then goes back into dormant.
Okay, so these things
What
drop
type of
very
magma
rarely
feeds
into the Hawaii. They're kind of cool to watch. So the basaltic, acidic, or rhyolitic? Yes. Basaltic, ocean, magma.
I would say, yeah, I think you could say that because coal makes a lot of dirt. Is all this molten magma that as it comes out, it cools down.
Well, I think probably the best way to envision it is like those fireworks. Kind of speed off the sparks. So that's why you
And then you're done. In fact, if you've ever actually gone out there after the fireworks are over,
happens a lot of times, especially with underwater
you'll see a lot of dust right at the base of the volcano, or the cones. You'll see the same thing with this volcano.
Okay, we're going to actually take a lot of
You
stuff.
get these layers upon layer
this
of
volcano.
gentle sloping land. So
Our volcano's not very
shield
large.
shape.
The other thing I want to mention about these, like I said, using very low silica, very low viscosity. That's a short clip on the video.
And that's because it is basaltic magma. Make sure you make that connection.
Just watch it.
Yes, you out, what I thought was kind of interesting.
See, I never put in that much.
Just wow, it's right now. I'm wanting at that moment in time in the video, it was an island.
So
That's what they actually
their notes
was eroding it almost as quickly as it built itself. So we have a basaltic magma volcano that was an island, and within a few days it's not. And we have very gentle eruption because basically in order to be an island, you got to be above the water. I guess I say gentle. Okay, so it's all within the ocean. But this is the type of eruption where you can get up very close and actually watch the eruption from being almost right on the edge. You can see
I mean, if you actually be up there watching this whole thing on replay, you're not really going to be able to see weird things. You know,
another type of eruption you will typically see with shield volcanoes are curtains, lava curtains. All right, so that's kind of our 3 things you need to know about volcanoes. And Iceland is a perfect example where you will see lava curtains. It's literally where the lava, as this eruption, there's a lot of pressure, so you start developing these cracks in the surface of your volcano. And then what happens is the magma travels up, and then these cracks are thin, but they're long. So then the magma comes squirting up through those cracks as these sheets. And that's why they call it looks like a curtain. It's just this constant up and down shooting of magma.
So is that kind of like